Today we're going to be looking at combinations, Chapter 10, Topic 3. Now, combinations are similar to permutations, except the order doesn't matter, okay? So what doesn't, a combination, a selection in which the order doesn't matter. So what does it mean for the order not to matter? Okay, so this would be N combine R, where N is the total number of elements, and R is the number of them we want to use. All right, well, the formula for this is N factorial over N minus R factorial times R factorial. Okay, so what does it mean exactly for us to want a combination? Let's say that we have a group of 4. 1, 2, and we have a group of 4, and we want a combination of 2. Okay, so 4 items, groups of 2. And our 4 items will just be the numbers 1, 2, 3, and 4. Well, if this were a permutation, we'd have 1 and 2, 1 and 3, 1 and 4, 2 and 3, 2 and 4, and 3 and 4. And then we'd also have 2 and 1, 3 and 1, 4 and 1, 3 and 2, 4 and 2, 4 and 3. I'd have 12 different options if this is a permutation. However, a combination, the order doesn't matter. Okay, so a group of 1, 2, of numbers 1 and 2 would be the same as a group of 2, 1. Okay, so if it's a combination, the order doesn't matter, so these would be considered repetitions, okay? These would be considered the same groups, so they'd be repetitions. So there's only 6 options for a combination in this case. So why is it that this equation works? The reason this equation works, n factorial over n minus r factorial times r factorial, is that it is a permutation. So if you think about it, let's consider 5 permute 2. Okay, so that would be how many ways let's do 5 permute 3. Out of 5 elements, how many ways can you permute it? So how many ways can you make groups of 3? Okay, where order does matter. Okay, so that would be 5 factorial over 2 factorial. But then you have to consider the groups where there's repetition, okay, where the order changes. Okay, like so for instance, maybe these are the numbers 1 through 5, 1, 2, 3, 4, and 5, okay? Which means that the group 3, 4, and 5 would be the same as the group 5, 4, and 3. Well, let's look at this group of 3. How many different arrangements are there for this group of 3? Well, there's 3 times 2 times 1. There's 6 different arrangements for this group of 3. And that's true for every group of 3. Every group of 3 has 3 different arrangements. So not only do we have, so that means that this needs to be divided by the number of arrangements there are for each group of 3, which is 3 factorial. Okay, well since it's dividing, we go into the denominator here. And now this is a combination because we're dividing out the repeated options. And this can be generalized, 5 combined 3. Okay, that would, this can be generalized, n combined r. Okay, well it's n factorial over n minus r factorial. That's just the permutation. And then we also have to divide out the number of repetitions. Well, the number of repetitions is just the size of the group factorial. Okay, well, so that's just r factorial. And now this is a combination because it divides out and gets rid of the number of groups that are repeated. which is right here, r factorial. That's the number of groups that are repeated. So now we can use this to, well, first we have a few examples here where we just calculate combinations. So 3 combine 2, so this would be three items to choose from, groups of 2 where order doesn't matter. So that would be equal to 3 factorial over n minus r, so 3 minus 2 factorial, and then also r factorial, so 2 factorial. Okay, so that's 3 factorial over 1 factorial times 2 factorial. Three times 2 times 1. 1 factorial is just 1. 2 factorial is 2 times 1. So it's just 3. You could have just calculated that in your calculator as well, but in this case, this is a little bit easier to just cross this stuff off. 7 items to choose from, groups of 4 where order does not matter. So the permutation for this would be 7 factorial over 7 minus 4 factorial, but we also have to divide out how many repetitions there are for each group, which there would be 4 factorial repetitions. This is 7 factorial over 3 factorial times 4 factorial. Now I could just do the canceling here, but I think I'll just plug this into the calculator. So that is 7 factorial divided by 3 factorial times 4 factorial, which is 35. Now your calculator does probably have a combination function. Okay, I don't know if this one does, but most calculators have a combination function. My handheld one has one, but it doesn't. Let me see. I don't know. This one probably doesn't have one. But some of them do have a combination function. So let's try this for some examples. A reading list for a course has 14 books. And how many ways can you select 5 books? So in this example, the order doesn't really matter, okay? 5 books is 5 books, okay? It doesn't matter if the first book is the first book or the last book, okay? It doesn't matter if, the Harry Potter book is the first book you choose or the last book you choose. It's still part of the 5 books, so the order doesn't matter. So this would be 14, choose 5, okay? Typically, that's how it's read, choose, okay, because you're choosing a certain number out of that group. So it's 14 options, choose 5. So that would be equal to 14 factorial over 14 minus 5, so 9 factorial. And then r factorial, which is 5 factorial. Okay, so we got 14 factorial divided by 9, what was it? 9 factorial, 5 factorial. So 9 factorial times 5 factorial equals, whoops, I forgot the factorial, dang it. 14 factorial divided by 9 factorial times 5 factorial equals 2002 different options, 2002 different ways. Number 2, a pizza menu has 9 toppings, and how many ways can you choose the 4 toppings? So this is a combination because any 4 toppings, it will make the same pizza. Doesn't matter what order you choose the toppings in. So this is 9, choose 4. So 9 factorial over 9 minus 4, 5 factorial, and then r factorial. Okay, so 9 factorial over 5 factorial times 4 factorial. So 9 factorial divided by 5 factorial times 4 factorial. 126. So 126 different ways to make my pizza here. All right, here is the assignment for the, there's probably more questions, you'll have to find it on Canvas.